So make sure you grab each of those handouts up front. If you would, leave the door cracked because there are probably a few more people coming in, and your seat's going to be on the board up here. Anthony Kong. Julia Cooper. Alberto. So you guys need the handouts up front. Blake Freeman. Let's see. Cooper, I think you're back here at 6. You need to take your headphone out too, sir. Oliver. No, you're in class, please. Oh yeah, y'all need to make sure you're in the right seat. That's how I'm taking attendance. I don't know most of you guys, so nobody's in your seat. You will be counted absent. Guys, if y'all are just coming in, you need the handouts up front, and you need to find your seat on the board. If you're not in the right seat, you'll be counted absent. No, if you're just coming in, you need to get the handouts up front, sir, and you need to find your seat on the board. You guys are going to be counted absent if you'll have to sit somewhere randomly. Okay, so for those of you that came in just a touch later, they are starting on a couple things. One of the handouts you have is a get to know you page, just a quick 5-6 questions so I can know something about yourself. So do that first, please. Second, you should have 2 pages that make up your syllabus, and you should read through that so that you can sign it. So I'll give you just a couple more minutes to do those things, but you can finish those up outside of class if necessary. You ready for the syllabus already? If you're ahead of everybody else and you happen to actually finish reading all the way through the syllabus, there is a way for you to sign it digitally on the bottom of the back page. So you're welcome to do that if you're just waiting. The getting to know you page, I'm not going to collect that today. I plan on getting that probably next class. I figured there's probably a couple people absent and I don't want to have to collect them multiple days. So as you finish that one, just put it away somewhere that you won't lose it. And you'll be ready to give that to me next time. And then just a moment more, and then I will skim through the syllabus, stuff that students often think to ask about, and then give you guys a chance to ask about others. And then we'll move on. So, sorry, I had the wrong slide up there. Probably, yeah. Ideally staple them together, but in the meantime, just put your name on both. All right, let's go ahead and if you're still working on the get to know you thing, just put it aside. You can finish that up quickly in advisory. You don't have to go super in depth on any of that kind of stuff. Just something to give me to work with to get to know you a little bit. So I do ask that you guys have a binder for this class. So if you guys know me from pre-cal, basically the same thing. But if you don't, it's pretty easy. I just ask that you number your assignments and keep them in order. I will say that for calculus, it's a little bit more important than pre-cal because we have an AP test. And when we get close to the AP test, you're going to have a good idea of what things you need to review and which things you feel weaker on. So you do want to be able to find your stuff reasonably easy. So one change I'm going to try to make this year is I'm going to try to number some of the handouts for you. So the syllabus has already been numbered number 1. So notice in the top right, there's a number 1 on 2 pages. Those are both the syllabus. This one's pretty long, but that's just because we choose to write out all of the things that we get to, the whole course description, although most of that's not going to mean anything to you. Generally, students are interested in grade makeup, so grades are the same as they were last year. 60-40, so 60 is the major category. That will be all of our big tests and big quizzes, and then minor is 40%, that's pretty much everything else. Late work, I do the same as I do in pre-cal, which is I will take late work, but it has to be fully completed. It's for half credit, and it has to be turned in by that assessment. So once we have the first unit test, I won't take any more late work from the first unit. Of course, that's also giving away easy points, so you really don't want any late work if at all possible. I don't know. That's all the main stuff that I think people ask about from the syllabus. We do have a final exam in fall that is required because it's an AP test, but we do not make you do a final exam in spring. So the exemption rules for exempting some of your finals is going to change, but you can't exempt our fall exam anyway, so that doesn't apply to us. Is there anything else that's jumping out at you about the syllabus? In just a few minutes I gave you to scan it. Okay, once you feel like you have read that, again, there's a link on the bottom of the back page where you can sign it digitally, but I ask that your parents also do that. But if you want to do your part and you read it, then feel free to. Okay, the second thing that goes in your binder, this one is not numbered as number 2. So even though I'm going to try to number the copies before I print them off, that's not going to work for everything. But it is this one. This is number 2. It's got 3 different things I need you to sign up for /bookmark. So the first one is my class website. And so that's where I'm going to put all of the resources that I have to help you. Whether that's videos to help with book assignments, but we don't do many book assignments. Extra practice places, solutions to check your answers on worksheets, all kinds of stuff. So you need to bookmark that one. So if you have your Chromebook with you today, just go ahead and bookmark it and then be done with it. The second box is for Google Classroom. Make sure that you use the second period code because this is second period. And then finally at the bottom, AP Classroom. Now I know most of you already have a College Board account, so just go ahead and sign in with your College Board account and use that key to sign up for class. But if for some reason you don't have a College Board account, you've never had an AP class before, they recommend that you use your personal email instead of your school email. The problem with using your school email is once you guys graduate, if you take any AP classes as a senior and then you graduate, you lose access to your school email. So I think it's hard for you to figure out your AP scores until your college university tells you. So it's a lot easier to just sign in and check them yourself during summer. At least that's what I have been told. So that would be next. So go ahead and bookmark that page, join the Google Classroom, and join the AP Classroom. I think all of those are important, but the AP Classroom, if you don't sign up for it, the school does not order you an AP test. And I can tell you every year there's always a few people thinking they're taking the AP test and then they find out that they're not because they didn't sign up for that. So joining the AP Classroom is what orders you an AP test at the end of the year. So let me give you a little head start there, and then I want to talk about my resource page just a touch, just so you kind of know what is there to help you, so you know when to use it. Again, those of you that know me already, it's pretty much the same thing that I do for pre-cal. It's got quite a bit more extra / suggested practice, just because calculus, some questions take more practice than what you've done in the past. So. But let me give you a few minutes there. Then we're going to review a couple quick topics. Logarithms and unit circle. And then we're going to jump into the first actual calculus topic. Oh, and I'll share just a little bit about myself too. It's 7203. So what I want to point out about the first one that you should have bookmarked while you go ahead and keep signing up for the others should look something like this. If you scroll down just a bit, it is going to be organized the same way I organize your binder. So you can see number 1, syllabus. Number 2, the handout you're using right now, websites to sign up for. I don't know why you would want an extra copy of that, but I link that if you need it. Eventually you can see that there's links to check your answers, suggested optional practice if you know it's something that you're struggling with. Sometimes with book assignments I'll have all the questions worked out, so if you need extra help more than we have time for in class, you've got that as an option. But pretty much anything that I think students have needed over the years I've tried to just kind of add to that. Up at the top is, the top right is always going to be the agenda. So the same agenda I had on the board when you guys came in. So this is good if you're at home, you don't remember what we did in class, you don't remember if you have homework, you can look at this and give yourself a quick 30-second snapshot. Or if you're gone, if you miss class, this gives you the quick 30-second snapshot. I also am going to continue to record classes this year. So I record myself and anything that goes up on the screen. And about halfway through last year, I started organizing that on a calendar. So right now, there's not a August the 15th second period link because that's right now and it's recorded. But if you go back later today, there'll be a link there. If you click that, it will show you the same thing that we go over in class. So that's really quite a bit of work for me, but I do it especially in calculus because there's going to be some topics that you feel like you need to hear the explanation to a couple times. So it's nice for you to go back and access that as you need it. And of course, if you're absent, there's a lot of little things, plus content, plus instructions, directions, all that kind of stuff. And so the class recording will give you all the same information as the students in class, and you shouldn't be behind at all. So that's why I asked that you bookmark that, because you should be using this one quite a bit. Okay, before I am going to ask that you get out a blank piece of paper here in just a second for our quick little review. But I am going to share just a few things about myself, and I knew some of you guys knew a lot of this already, so I did try to squeeze in a couple different things. Just some basics and stuff that students often tell me that is just slightly more interesting. Oh. So this is going to be my 18th year as a math teacher, I think, if I counted up correctly, and my 4th year in a row that I'll be doing pre-cal and calculus, which I'm very happy about because those are definitely my 2 favorite classes. But I've taught all of those at some point that I have listed there, some of them more than others. I am the department chair for math department. My dad was a math teacher here for a long time, so if you have an older sibling or if your parents know of a Townsend math teacher, it's probably my dad. It probably wasn't me. And I was a student here at Fayetteville Schools, Bates, from kindergarten to 6th grade, which doesn't exist anymore. Bates used to be where your cafeteria is. They bulldozed it to make the high school a little bit bigger. And back then, Ramey was 7 through 9, and Fayetteville High School was only 10 through 12. That changed a few years back. I have a bachelor's degree in mathematics and a master's degree in education. Both of those are from the University of Arkansas. Since I went to school here, there were several teachers that I had that are still around. So if you recognize any of those names, I listed them and I tried to put down what class I had them for. I guess just depending on if you've ever had them as a teacher, you may not know them. The one that most of you probably don't know is Mr. Young. He used to be a science teacher, but he's an assistant principal now. You guys know any of those teachers? Probably Mr. Adams? No? I think it might be his last year this year too. And I'm assuming quite a few of you have Mr. Reef this year. You're doing AP Physics? Nobody's doing AP Physics? Just 1? 2? I'll be turning 40 here in about a month. I've got 1 dog, been married for almost 7 years to my wife Jessica. My biggest time waster / way to relax is video games. two games I've played the most is Dota 2 and Rocket League. So if you've ever played those, then let me know so I can talk to you about it sometime. And probably my favorite games of all time would be Ocarina of Time and Mario 64. But those might be too old for you guys now. Has anyone ever played either of those? Yeah, which one? Okay. I want to go back and play it again. I'm just afraid it's going to be like too dated. The graphics are too old now. I'm sorry? Oh, yeah. High school, I wasn't a great student. I really enjoyed learning things, but I just wasn't big into busy work, so I'd usually just take a lower grade before I would do busy work. Haven't had a sick day in about 9 years now. I'm up to 132 sick days, but the district doesn't let me save up more than that. And when I got married almost 7 years ago, we got married on a Friday, but we had the ceremony after school. So I still came to school and then we got married after. But she was a slacker and took the day off. And almost 2 years ago, I had made a plan for myself about working out. After about 10 years of not working out, and sitting around for almost 2 years of COVID, I just was starting to feel super lazy, low energy. So I made it one full year where I worked out every single day, even if it was hot, cold, sore throat, sick stomach, busy day, long work day. And so I was very proud of myself. It was very mental challenge to do it every single day. And so I still do it pretty actively, but I do take off a day or two a week. I'll let myself take time off for vacations and being sick and stuff now. So I tried to calm down on that a little bit because I don't know. I'm not trying to be a bodybuilder or anything. So. And the last thing is, as far as I know, I've never had COVID. A couple times I've had the symptoms, but I tested and always came up negative. So as far as I know, I never had COVID. So that's all I've got for that. After that, we've got, okay, so I need you to have a blank piece of paper. And if you don't have any paper, since it's birthday, I do have a little bit of extra, so raise your hand and I'll drop you off. Anybody else need paper? Okay, so by far, the hardest part of calculus is it's really everything that has accumulated throughout all of your math courses. As far back as fractions, add, subtract, multiply, and divide, as early as unit circle, or as most recently as unit circle. But in calculus, you also have to know a few geometry formulas and a ton of algebra and factoring and graphing and using your calculator. Usually it's not the calculus concepts that students struggle with or have a hard time remembering. It's the execution of all of the past math stuff that we do. So starting last year, we decided to just kind of start off with a little bit of review. So the piece of paper that you got out, you need to number it as number 3. So just put a big 3 in the top right. And when you have a binder for this class, it goes behind number 2. And that's all you have to do for the organization. It's really just about 5 or 10 seconds a day. But don't let yourself fall behind on that. So we're going to review unit circle real quick and some of the log properties you need to know, because this stuff is sprinkled in throughout the year. Unless we change something, I know that in second semester there's a test question where you might do 4 or 5 steps of calculus, but the last step is you have to know a log property to finish it and to pick out the correct multiple choice answer. So if you don't know the log property, it doesn't matter that you can do the calculus, unfortunately. So we're going to review that, and then you can see that we have a plan to give you a short mini quiz over just these 2 things, unit circle and log properties. These are things you're supposed to remember. We're reviewing them real quick, but if you need to study them, or if you've never learned the unit circle well, then you need to do that between now and Thursday, because we just use it all the time. So, okay, so for the log properties, I'd like you to go ahead and write these 10 questions down, just a small sample of applying some of these properties. And we'll discuss them, and then you should just put little marks by the ones that you need to review. Not all of these are going to make the quiz. Also, the quiz is not going to be worth a lot of points. It'll probably be like a 10-point quiz. and it will be a minor grade. So by the end of the semester, it's not going to impact your overall grade hardly at all. But of course, the first few weeks you don't have many grades or any grades. So this first quiz will kind of make your grade look good or bad here at the start. Okay, and you guys can just write them down as we go over them. So you don't have to write them all down before we start. Okay, so the first little property says if you have a number, some generic number A, and it has an exponent that's log, and the base is the same number, and you're taking the log of B, does anyone remember what all of that simplifies to? Just B. So it may look like that on the quiz, or it might be numbers. It might be 7 to the log base 7 of 10. You should be able to tell me that that's 10. Okay, question 2. Log base A of B to the power of C. You guys remember what we can do with this C? What's special about that?
Bring it to the front.
Right. You can bring it down to the front. If it's an exponent on something you're taking the log of, we usually bring it down. Occasionally, we actually bring it up, but usually bring it down. Okay, 3, 4, and 10 are all kind of similar, but for 3 and 4, you have to know the base. So in question 10, if there's no base written there, that's an understood base 10. And you need to know how to read this. This is saying 10 to what power gives you 10, and that's why your answer would be 1. Question 10, skip over here. This is saying 5 to what power gives you 25. So not 5, it's not multiplication, it's exponents. 5 squared gives you 25. Same thing with number 4, but you need to remember that natural log means log base E. So if you want to scratch that out, change it to log base E, it's exactly the same thing. 99.9% of the time in calculus, when we do logarithms, it's usually natural log. Almost always natural log. So this is saying E to what power gives you E, so that's why it's also 1. But to me, 3, 4, and 10 are basically asking the same thing. It's just that 3 and 4, you have to know what the base is. It won't be told to you. All right, 5, 6, 7, and 8 are all about expanding and condensing. So let's skip to number 9. Remembering how to take something that's in exponential form, like A to the B equals C, and change it to logarithmic form. So logarithmic form is going to have log out front, and B and C would switch places. Now again, I'm not saying that we use this all the time in calculus, it's just that it will show up sometimes in calculus, and I just don't want you to miss more points than are necessary from past knowledge stuff. Okay, the other 4 have to do with expanding and condensing. So questions 6 and 7 go together. Expanding, if you're taking the log of something times something, you can split it up with, what did multiplication change to? Changes to addition. Likewise, number 7 is going the other direction. If it's 2 logs of the same type are separated by addition, you could condense them with multiplication. 6 and 7, same thing, just both directions. Question becomes the answer, answer becomes the question. And then the only other way to expand and condense would be like 5 and 8. A log of something divided by something, you can split apart with subtraction. So if you want to expand, it's subtraction. If you want to condense, subtraction becomes division. Okay, make sure you got all of that copied down and see if there's anything you want clarification on. Any of these you want me to make up another example or two for, or make up an example with numbers? Any questions about how this might show up on the quiz next time? Just a very quick 5-minute quiz. This one will not be multiple choice. Most of our big tests we format the same way as College Board does. So usually we do multiple choice and an FRQ or two. But our first one, our first big test has a couple not multiple choice, just fill in the blank. But especially as we get closer to the AP test, it's like that. But little quick quizzes, no, they're usually just fill in the blank. Okay, so I'm going to take just a couple of those, so it could be anything from that, but the other thing that you need to know, probably more than logarithms, at least for this first unit, is unit circle. So for unit circle, we've got certain locations, of course, that we have to know. And so really there's 3 values that show up a lot. All these dots in red are almost the same. All of the dots in red have an x length of square root of 3 over 2, 1/2. The only difference is in quadrant 2, x is negative. In quadrant 3, they're both negative. And in quadrant 4, y is negative. But otherwise, all the red dots are square root of 3 over 2, 1/2. All the middle dots, the purple dots, are square root of 2 over 2, square root of 2 over 2. And again, only difference is quadrant 2, x would be negative. Quadrant 3, both would be negative. Quadrant 4, y would be negative. And this one is 1/2 square root of 3 over 2. So all the black dots are the same except for the dots. Now, of course, this is not how it's going to be asked. You're not going to have a calculus question where they say construct a unit circle. Unit circle questions are going to be like these that I have listed over here to the right. So we're just going to use a couple of these as examples. Your quiz will probably have different questions, but this is enough to show you if you need to study it. Okay, so when we memorize the unit circle and we memorize all of these points, what do these points tell us? How does this help us answer questions like these over here? I'm sorry?
The coordinates.
Okay.
The coordinates of
Okay,
each
assigns the
degree.
y value. Okay.
And the coordinates of each degree.
Okay, the coordinates at each degree. But what about, okay, so you said sine is the y value. Okay, what's the x values tell us? Okay, so each one of these points cosines the x value. So if you know where 30 degrees is, it is just the x coordinate there if you want cosine. Sine of 30, you would need to know where 30 is. You need to know the coordinate there. And sine is the y value. So every one of these points, when you memorize this, or you see the pattern, whenever that was, you really are memorizing a bunch of sine and cosine values. So if each of these show you sine and cosine, there's still 6 trig functions. By far, the ones we use the most in calculus are sine and cosine, but tangent comes up a lot. The others sometimes show up. And of course, you should have learned this at some point, so it should just be a quick little review. But for tangent, you should do sine of that angle divided by cosine of that angle. Of course, at 45, sine and cosine are equal, so anything divided by itself is 1, so that's an easy one. What about cosecant? How are you going to find cosecant values? Yeah.
It's just like the inverse of sine.
Close. Not inverse, but reciprocal. You're thinking the right thing, but so if you know the sine of 30, cosecant's just the reciprocal of that. Flip your fraction over. If you know the cosine of 30, flip the fraction over, and you've got secant of 30. Just reciprocals. Now, sometimes you need to rationalize, sometimes you don't. It's not nearly as important as it was in trig and pre-cal, but it's a good idea to practice rationalizing just in case you get a multiple choice question someday and you need to do that. I don't want you to miss it because of that. Okay, and then cotangent's the reciprocal of tangent. So if you know the tangent of 45, you can flip his fraction over and you've got the cotangent of 45. Really, the bulk of the unit circle work is knowing the sine and cosine values, which is knowing this circle, knowing the locations, knowing cosines x, sines y, knowing how to use those to find tangent, and knowing how to flip those to get the other three. Again, I know that's super quick, but this should not be the first time that you've seen this. You guys did pre-cal last year. It's pretty much sprinkled in all first semesters. So other than being rusty, because you probably haven't used it much over the summer, you shouldn't need to study this more than 5 or 10 minutes, hopefully. But if you do, then please do, because it will show up all year. Don't start off at a disadvantage. Okay, before we go on, I want to give you just a second, and I want you to try these three at the bottom, just to give yourself a quick little snapshot if you really know this as well as you think you do. So, give your best effort on those three, no calculator. We will check them, make sure you don't have any other questions, and then we can move on to our other handout. I was thinking that you were going to be here today. Okay. You're not going to be here Thursday.
Next month. I think I put the date in.
Oh, okay. That makes more sense.
Yes. Thank you.
Okay, just 30 more seconds. Okay, and obviously if you missed something, make corrections, but please mark that question too so you remember that's one you missed and you know what to look back at. So to answer a question like 17, you need to know where 5 pi over 4 is. So if you know how big 1 pi over 4 is, you can just count it out 5 times. 1, 2, 3, 4, 5. Sine is going to be the y value. It's in the middle, so it's going to be the same as this purple dot's purple dot. And sine's the y value. The only thing you have to be a little bit extra careful of is down here in quadrant 3, x and y are negative. So that would mean sine and cosine are both negative. Only correct answer to 17 is negative square root of 2 over 2. Now, of course, if you miss some of these and you realize you need to study, be mindful of what it is you need to study. Is it that you need to practice constructing the unit circle 3 or 4 times? Is it finding the location of these? Try to hone in on that a little bit. Okay, for tangent of pi over 3, you have to know where pi over 3 is, 60 degrees. And we know this is cosine and this is sine. But using those, you can use those to get tangent, because tangent is always, bless you, sine divided by cosine, and then you can change it, keep, change, flip. And so the only correct answer to 18 is square root of 3. Okay, and then cotangent of pi over 2. So pi over 2 would be half of pi over 2, which would be right here. If tangent is sine divided by cosine, and cotangent's the reciprocal of that. Cotangent would be cosine divided by sine. 0 divided by 1, which becomes 0. Again, these aren't the same questions. The short quiz is not trying to trick you, but these few questions should help you see if you need to study 30 seconds or 30 minutes. So, couple unit circle, couple logarithms. Yes?
Where's the test gonna be?
The first major test is not for a couple weeks.
Oh no, like the small test. Like.
Next class. Start in next class. So your only homework is going to be, the rest of the stuff we talked about the rest of the class is not going to be on the short quiz. Just these two things. Okay. Any more examples you guys want? Clarification? I really don't mind, but you guys do have to learn to speak up.
Can you go over like how you figure out like that's pilot and that's
Sure.
pilot?
What I do is honestly what I do is I memorize two of them. I memorize this one. You know, this is pi over
6.
6. To right here is pi, right? So this is like a sixth of that. You see how this slice is like 1, 2. Am I counting that up wrong? Oh, these aren't actually evenly spaced. Is the problem. Here's 1 pi over 6. Here's the second slice. So here's 2 pi over 6. Add that distance again, you get 3 pi over 6. Add it again, 4 pi over 6. Add it again, 5 pi over 6. Add it again, you get 6 pi over 6. So if you know how much 1 pi over 6 is, 30 degrees, you can just add that to find 2, 3, 4, 5, 6. And then you can keep going down here. You can add it again for 7 pi over 6, 8 pi over 6, 9 pi over 6. What should it end up at?
2 pi.
So 10 pi over 6, 11 pi over 6, and then 12 pi over 6. But of course some of these reduce. So we don't say 2 pi over 6, we just say pi over 3. This reduces to pi over 2, 2 pi over 3, pi, 4 pi over 3. We just reduce our fraction anywhere we can. And we don't usually say 12 pi over 6, we say 2 pi. Okay, so that's almost all of them, but I said I memorized 2. The other one that I memorized are the ones in the middle. I know that this is a fourth of the way to pi, so this is 1 pi over 4. Add it again, you get to 2 pi over 4, which reduces, and we knew it anyway. Add it again, you get 3 pi over 4. Add it again, you get 4 pi over 4, reduce, and we know it. Add it again, 5 pi over 4. Add it again, 6 pi over 4 reduces, and we know that one again. Add it again, 7 pi over 4. Add it again, 8 pi over 4. But that reduces and confirms. We already knew that one. So you get a little bit of redundancy, but that's okay. So if you know how big 1 pi over 6 is, you can just count 12 of them, and you can get all the important spots. If you know how big 1 pi over 4 is, you can count all of those, all 8 of those, and you get all the other important spots. Some of them you get multiple times. Okay, is that what you were asking for?
Yes.
Okay. Anybody else have a follow-up to this one, this question? Okay. Anybody have another question or example you'd like to have? Okay, then let's move on. The other two handouts you have, I think, should be numbered. These should be 4. Now, I will be honest with you, used to limits, which is the first thing that we do in calculus. All calculus classes start off with limits. Really can be some of the most stressful for students just because it's a new year. Limits don't always click with everybody right away. I don't know, it's often one of the things that students feel like they need to review before the AP exam. Part of that's because we do it early in the year. But if you guys did pre-cal last year, we did a couple weeks of limits, and the reason why we did that is to make it a little bit smoother for you. So if you did this last year in pre-cal, it should be a little bit easier the first couple weeks, and if you haven't done this before, you might have to put in a little bit more time and effort than the others around you. But calculus really boils down to 3 big topics. We have, well, I'm going to do a flow chart for you guys some other time, but calculus really boils down to 3 things: limits, derivatives, and integrals. We only spend 2 to 3 weeks on limits. That's what we do at the beginning of the year. Then the rest of the first semester, we practice taking derivatives, what a derivative means, and applications of derivatives. There's lots of real-world applications to derivatives, which is why you need calculus if you're going into engineering or anything like that. And then second semester, we do integration, which is really just the opposite of derivatives, opposite process, just like division's the opposite of multiplication or inverse. Applications of integration, it does some really cool real-life stuff that you probably wouldn't think was possible until you see it. And then we try to wrap up all our new stuff by spring break, and then just do AP review from spring break to the AP test. So 3 big things: limits, derivatives, integrals. Realistically, we do 5 big things: limits, how to take derivatives, applications of derivatives, integrate, applications of integration. So, but the reason why everybody starts off with limits, I say all that just for this. Derivatives, the idea of a derivative and the way an integral is set up and defined, they only exist with the idea of limits. So we have to start off with these, otherwise the other questions just really don't even exist or make sense. Okay, so the part we're going to look at today is just the graphing part. What does a limit look like visually? What's a left limit, a right limit, and what if it doesn't designate? So we got 2 pretty strange looking graphs here, ones that are a little bit harder to read. And I've got some examples I want to go over with you, and then I'll have you practice a few. So this first question reads, what's the limit of f of x? So we're looking at the left graph. As x approaches 3, and then there's a little negative sign. This little negative exponent means from the left. So you go to f of x, you're going to look around where x equals 3. Now the biggest mistake that students make here is they kind of overlap too much about points versus limits. Limits are not the same thing as points. What a limit is asking you is what y value does it close to as x approaches 3 from the left. So as x gets closer to 3 from the left, I can see that the y value gets closer and closer to 0. That's all a limit's asking for. What y value is it approaching? Now, if it's got a little plus looking exponent, that means from the right. So you would take a number slightly bigger than 3, head towards 3, and think about the y value that it's approaching. I don't care if that point exists. I don't care if that point is some randomly way up here or way down here. All I care is what is it approaching from the left and from the right. And then if it doesn't say left or right, this means both. So if it's approaching 0 from the left, 0 from the right, then the limit from both would be 0. Okay, the only difference with 4, 5, and 6 is now we're looking at g of x and a different x value. So we're looking at the graph to the right. As x approaches 1 from the left, looks like it approaches a y value of 1. But from the right, it's approaching a y value of negative 1. See, they can be the same thing. They were both approaching a y value of 0 here, but they can be different. This one's approaching 1, this one's approaching negative 1. But if it's approaching 1 from the left and negative 1 from the right, if these are not the same, then the limit for both can't exist, does not exist. It's got to be the same from the left and the right. Okay, and then one more with some infinity stuff. G of x as x approaches 4 from the left. That would be right here. Looks like this guy goes up forever. So that would be infinity. And while that may not seem like a big deal, this is your first time in your math career where you have an equation that can equal 0. Limits can actually equal infinity. Before, you always just had to say that it approached, but with limits, you can actually have an equation that equals infinity. What about from the right side? Okay, from the right side of 4, it's also going to a y value of infinity. Now again, limits don't care if it's there. Obviously, you can't reach infinity. It cares what it's approaching. These are shooting straight up, so they're both approaching infinity. So the reason why I have this one down as a third example is I'm going to suspect most of you guys are going to say the answer to this is what? Infinity, because the left and the right are the same. The AP test does it that way sometimes, and sometimes they say does not exist. So you need to put both in your notes. Infinity and negative infinity are not numbers, they're just ideas. So that's why they sometimes list that as an answer. Hello? Yes. I'm sorry, who? Okay, purple office. Okay. Thank you. Anthony, you need to go to the purple office. So I say that because, again, when we get to a test and some of it's multiple choice, the answer could be infinity if that's what they have listed, or it could be does not exist if that's what they have listed. They wouldn't list both. They could list one or the other, so you need to be aware of each. Yes, sir.
How do you know which one to use?
You can write either one. If I was you, I would say does not exist, just because it's a little bit safer. Like on a free response, if this was one part of the question, let's say you thought the answer was infinity, but it was actually negative infinity. If you said did not exist, then you would still get the point right. So it's just a little vaguer, but technically both are fine. Both are fine on free response. Multiple choice, it may list like this or it may list like this, so you have to be aware of both. Okay, so to see how that went, I've got a sample of 9 questions. Some of them are from the left, some are from the right, some are f of x, some are g of x, all kind of scrambled up. But if you really know what you're looking for there, you should be able to get all 9 of those correct. So I'm going to give you a few minutes to give that a shot. And again, just to be clear, this will not be on Thursday's mini quiz. But if you feel like you're struggling with this stuff, of course you should do yourself a favor and start to look at it here and there. You don't want to feel overwhelmed when we get to the first test. And for those of you that work a little bit quicker, you might want to read the top of the next page. It's got a couple of properties that you're supposed to know. So if you're just sitting there waiting, you can do that. Okay, let's compare answers here. Here's the 9 that I got. So you need to tell me which ones you got something different on so we can talk about them in detail. Yeah.
I got 16.
On which one?
You try.
Which question number?
16.
Okay. What'd you get for an answer?
I got 0.
0? Okay, let's see. So f of x as x approaches -3 from the right. Okay, so here's -3. So from the right it's going to be where it's a little bit bigger. Looks like it's approaching a y value of 4. Now notice there's an open circle there. That point doesn't exist. That's not what limits care about. Limits just care what y value is it approaching. So I think 4 is still good. Is that what you needed?
Yeah.
Okay, we had another one. Okay, I do want you to add one thing to this one, number 17, because part of what makes our AP test pretty difficult is they're very picky about justification. And the way you would justify 17 is probably not what they would be looking for. So, just in words, why does this, in 17, why did this one not exist?
Both the limits equal different things. They approach different things from the left and the right.
Okay, that's good. And the most concise way to say that, though, with math terms, like if this was a free response, they're going to want you to say the limit from the left is not the same as the limit from the right. I'm not saying that you can't say the same thing with words, but usually when students try to explain things in a sentence or two, they usually either are not comprehensive enough or create a hole in their logic or something. But this is just a good example of justification. It's not the same from the left and the right. Okay, last chance. Any of the other 9 you guys want to talk about? Yeah.
The 13, could you also say that it's not continuous and nothing?
Well, continuity is a whole different thing. Limits don't care about continuity at all. So we'll get to that in a couple weeks, or in about a week. But as far as the limit goes, you need to say it doesn't exist. Don't say that it's not continuous.
For the justification.
No, because they're not the same thing. If I made a graph like this, let's say this is 3, this is 4. What's the limit as x approaches 4 of this function? This is not continuous because it's got a hole in the graph, but the limit from the left and the right are still 3. So continuity has nothing to do with limits. Or your answer to a limit question is not dependent on continuity. Okay, on the top of the next page, we've got some properties. These are generally the easier ones. So we're going to look at one page of that. And so these 5 are ones that students don't usually struggle with. If you want the limit of something, of a function plus a function, you can just work the limit separately and then add the answers together. Same with multiplication, work them separately, then multiply. Same with subtraction, work them separately and subtract. Same with division, work them separately and divide. Now, even though this doesn't seem like a problem to you right now, when we get to derivatives, add and subtract works this way, and then multiply and divide, we have to do different rules. So this works well for limits, and so we just need to kind of have that good foundation so it's less confusing later. And then if you have your function multiplied by a number, you can just work the limit out and then multiply by that number. It's just going to make it that much bigger. These 2, I don't ever think are a big deal, but students sometimes struggle with them. If you take the limit of a constant, it's going to equal a constant. So let me just make up a number. Let's say that c is like, I don't know, 2. Y equals 2 is a horizontal line. So regardless of what x value you're approaching, it's always approaching that c value. And then this one, if the function is x, that looks like this. So if you're approaching 3, you would be approaching a y value of 3. If you're approaching -1, it's going to have a y value of -1. So whatever you're approaching is what the limit's going to be. So if you just think of this as a graph, horizontal line, or this as a graph, y equals x, then it's really no different than what we did on the first page. Okay, so a couple quick examples, but again, if you can do the first page, I guess this is a little bit harder because there's more room for mistakes. But basically, for 19, I can work out this limit question, just like I did earlier. Looks like it's 0 from the left and the right. Then do it for g of x. Looks like it's -4. And since it says add, we're going to add those together, and then that's where the final answer comes from. Twice as much work, twice as many places for mistakes, but otherwise shouldn't feel any more difficult than the front page. Number 20, -4. Now also with these graphs, I know some of them aren't perfect. Just line up the best that you can. I'm not trying to trick you or anything with any of the numbers. Not like 4.1 or anything. So I would say this approaches 4. I would say this approaches -1. And then it says subtract them. So subtract them. (21) Take the limit as x approaches 0 of f of x. Take the limit as x approaches 0 of g of x. It says multiply, so multiply, and that's where your final answer should come from. Add, subtract, multiply, divide. Work them separately, and then add, subtract, multiply, or divide. So using those same two graphs, there is one more small set that you need for a quick little check. That would be 22 through 30. So try those, see what you come up with. So guys, as I come around, if you guys have any quick questions, always feel free to ask, but I'm just trying to get a general idea of how much more time I'll be. I will. Yeah, I will share my answers. 'Cause if you're doing something wrong, now is the time to figure it out. We do stick with limits for a couple weeks, but graphing like this, we really only spend one day on. So. These aren't questions that most people feel like they need to practice 100 times. Let's give everybody 30 more seconds. Okay, first off, let me share my answers to these 9. Well, I shared 8 of them. There's one of them I want to discuss with you. That's number 26. So, make corrections if you need to. If you disagree with any of these, please let me know. I will tell you, when I did this yesterday, I think I missed 2 of these 9. Because you do have to be careful which graph you're looking at. And I did it too quickly. But that's a good lesson for y'all to learn, because you know how to do it. If you're zipping through it, you're going to make lots of careless mistakes. So, from these 8, any of these you want me to tell you how I came up with the answer? Yeah. Okay. 27. Alright, so the limit as x approaches -2 of g of x first. So -2 from the left and right. I called that -1. Again, just to kind of guess here. So that's where that came from. Then I did the limit as x approaches -2 of f of x. So from the left and the right, it appears to be 2. And then since it said subtract, I subtracted them. -1 minus 2 gave me the -3. Okay, any others? No. Okay.
What about 26?
Okay, yeah, well, I just wanted to do that one at the end. Alright, so looking up above, I don't have the graph in front of me, so you'll have to help me out here. On f of x, what is the limit as x approaches 4?
1.
Okay, everybody get 1 for that part? Okay, what about the limit as x approaches 4 of g of x? I disagree.
It doesn't exist.
Okay, why does it not exist?
It's not approaching from the x.
Right, for a limit to exist, you got to approach the same thing from the left and the right. This graph doesn't even exist on the right, so it can't have a limit as x approaches 4. It's got to be the same from the left and the right. It doesn't exist over here, no limit. So really, it's kind of like 1 plus does not exist. So in this case, we'd have to say does not exist. Yeah, Julia?
On 23, I got 4. I kind of just read the graph wrong, but can you go over that?
Sure. As x approaches 3, g of x, what did I call it, 4? Oh, I called it 3?
Mm-hmm.
Yeah. So I don't know.
Wait, isn't it positive? I think it's +3.
Oh, it's +3?
Yes.
Okay. Yeah, I think I estimated that as 3, 4. I could see why you would say both.
Okay.
Graph would always be clearer on a test. I really just need to add some like faint lines to these graphs, but don't worry about that. Okay, then let's move on to the next page. So that page has all of the fairly intuitive properties, the ones that people, yes, you still need to review them, but you probably don't need to study them a lot. But the next page has one property that is a little bit of a process. It's not hard, but it's not intuitive to most people. And that's how to take the limit of a composite function. So when you have a function plugged into another function. So we're actually going to only do the limit once. We're going to do the limit of the inside part. That gives us all of this. That's going to give us a number. And then we're going to plug that into the outside part. But then that's not going to be a limit anymore. This is just going to be about a point. So my 3 examples that I have for you guys have all of the steps laid out, but what I really want to know are the questions to these on the far right. So to answer a question like 33, what's the limit as x approaches 1 of f of g of x? I'm going to do the limit of the inside part, which is actually question 31. So this is what we've been practicing this morning. From the left and the right, it appears to be 0. That gets plugged in to the outer part. And f of 0 has nothing to do with limits anymore. Calculus is finished. What does f of 0 mean? Okay, so on f, when x is 0, it's saying it just wants the y value, right? And if you do both of those things, that's how you get the answer to that limit question on the far right. So let me try to summarize that 2 more times in the next 2. If I want to answer question 36, I would do the limit of the inside part, which is question 34. Looks like that would be 2 from the left and the right. That gets plugged into the outer function. But f of 2 means you go to graph f. When x is 2, what is y? I'm going with 1. Looks like 1 to me. But when you do that, that's how you get that final answer. You got to do these 2 steps to get this answer. So limit of the inside. Now f of x isn't always on the outside and g of x is always on the inside. You got to pay attention. On 39, f of x is in the middle or in the inside. So I'm going to do the limit of the inside, which appears to be 2. That gets plugged into the outer part. And g of 2 means you go to g and give the y value when x is 2. And when you do both of those things, then you have the answer to the question we actually care about on the far right. Now, the 3 I want you to practice are not set up the same way. It's not do this, then do this, and then there's your answer. Do this, and then there's your answer. I don't have it spaced out that way, but just 3 of these type with different graphs. So try that, and then we will move on to the last page. Last page has some pretty tricky questions, but it's good for y'all to at least see them once. We don't tend to put those on our test or anything, but the first 3 pages here, you should expect a question or 2 to show up on our first test in a week or 2. So for 40, I don't have these answers pre-made, but that's okay. Doesn't take but just a second to describe the process. Do the limit of the inside, which should be -2. That gets plugged into the outer function, which is f. And this is asking for the y value on f when x is -2, which should be 2. Y'all got that one? Good? Okay. Okay, switch to order. Now f is in the inside, so I'm going to do the limit as x approaches 3 of f of x. Looks like that's 0 from the left and the right. And that gets plugged into the outer function, so the final answer comes from g of 0, which should be -2. Still good? Okay. And then 42, the limit as x approaches -6 of g of x. Well, does that exist? I'm seeing some yeses and some nos. So on the other page, I'm trying to not trick you guys, but I'm trying to make sure you're paying attention. Remember we said this one up here didn't exist because it doesn't come from the right? Well, -6 is like over here. Does it ever go over here? Yeah, that little tiny arrow makes it all the difference. You wouldn't think that that would make that much of a difference, but it approaches 2 from the left and the right. That gets plugged into the outer function. Your final answer comes from plugging that into f. Looks like another -2. Now, full transparency, if we put this on your first test, it's probably going to be one question only. If it's on your AP test, it's probably going to only show up as one question only. But, of course, you want to be able to get it right, and it's not like this process is hard, but if you don't review it a little bit, then you're probably not going to remember it on the spot. So, any questions y'all want to ask to finalize that? Okay, I don't want to rush too much on the last page, but again, these are kind of the tricky questions. We would not throw these at you on our test, but just for your calculus knowledge, and if you like kind of some trivia type questions, I don't know, it's good for y'all to see these. So let's say I wanted to know the limit as x approaches 0 of g of x times h of x. Well, one thing I'm going to ask myself is, what's the limit as x approaches 0 of g of x? So I'm going to do these. I'm going to think about the limit from the left, the limit from the right, and since those are the same, I know the limit is 0. But then if I think about the left and right limit of h of x, it looks like from the left it approaches -3. From the right it approaches, I don't know, a half, or 1 if you want to call it that. So what would this say? Does not exist. Well, how we did this 2 pages ago is you would multiply these two results. But what is 0 times does not exist? Sometimes. Sometimes 0. Sometimes does not exist. And it actually could be anything. So what makes these questions kind of weird, like if you're not really sure which one it is like this, you have to think of them one step at a time. You have to think about the left limits multiplied together. So the limit as x approaches 0 from the left of g of x times h of x would be 0. Then think about the right limit of the multiplication. 0 times a half would be 0. So really the left limit is 0 and the right limit is 0. And if the left and the right limit are the same, then it technically can have an answer. Can be 0. But again, we normally don't think of it in that direction. So sometimes you need to do the multiplication of it to look at the left, multiplication of it to look at the right, and if the left limit equals the right limit, then you can work it out that way. Okay, another one would be like this composite function. So I know I would want to do the limit of the inside part. So to do that, I'm going to do the limit from the left and the right of g of x as x approaches 0. 0 from the left, 0 from the right, so that's going to be 0. We already did that before. Now, what makes this one kind of tricky is that on h of x, it kind of goes to two different things depending on what side you come from. So, even though, and again, we don't test you on this, but you will probably see this at some point in your calculus career, unless this is the only calculus class you ever take. Do you guys see how when I did this limit, I come from the left and it approaches 0, and I come from the right and it approaches 0. But do you see how technically it's always above 0? Both sides are coming from above. So even though it's getting close to 0, we still say that it's slightly bigger or above. So from the left, this guy is approaching -3, and from the right, he's approaching 1/2. The way we know which one to do is we want the one from the upper part, where it's a little bit bigger. Because if these are slightly bigger than 0, then we should be looking at the one that's coming from the right side of 0, because it's also slightly bigger. So that's why the answer to that one would be 1/2 and not -3. That's how you know which one of those to consider. Again, just the fact that these were both above 0 means that the second half of the problem, I'm coming from the right because that's above 0. That's really all it boils down to. Okay, why don't you guys try 45 real quick, and I'll work it out the same time as you, and then we'll have at least one more to compare it to each other, and then I'll remind you what you need to have ready for class on Thursday, and then we'll find a stopping place. Okay, so all these leading questions, I'm trying to push you in the right direction. You guys agree with everything I have written down here? Okay, so the point of this is, again, I don't want to spend too much time on it just because you won't be tested on it, but because both of those are approaching 2, but it's always below, that means it's kind of a little bit under 2. That means you should use which one of these two? That's when you want a number bigger than 2. 2 from the right means it's going to be bigger. You need it to be positive infinity. 2 from the left means your x value is getting close to 2, but it's actually a little bit less than 2. Since these are below, that's also like less than. It's below. So you could say infinity, or of course you could just say does not exist, because that's a safer bet anyway. Okay, so if that is overwhelming to you because you didn't do it last year or you forgot it all, do yourself a favor and spend a few minutes soon on it. Don't wait until the test when you've got 10 other things on top of it. Just make sure you're caught up to speed. But also, before you put your stuff up, make sure you have some kind of alarm set to remind yourself to review unit circle and log property squares. Just be 5 to 10 points, minor grade, not a big deal, but it will be your first and only grade for a while. So if that's important to you, then make sure you're prepared.